Welcome back, everybody. So what we're going to do in this lesson is we're actually going to take what we learned in the last two lessons about translations and combine it into two examples. So you'll notice I've already got a few things set up here. So on the left, we've got the graph of f of x equals x squared. And we are going to consider the function g of x equals x minus 1 squared plus 2. And then we have another example on the right that looks at the square root function. So we'll look at that in a minute. Now, I'm going to try to recall for you some of the things that we did in the last two examples. So I'm going to actually take in red and I'm going to underline all of the transformations. So x got replaced with x minus 1. And then we now have this plus 2 on the outside. So again, I'm going to zoom in because I like the way my writing looks better when I do. But I want you to think about what are the transformations here. Okay, so let's write out the transformations. So the first transformation that I underlined is replacing x with x minus 1. And so I hope that you remember from our last couple of lessons that replacing x with x minus 1 results in a shift to the right by 1 unit. And then the second transformation that I underlined results in a shift up. That plus 2 on the outside, that's a shift up by 2 units, okay? And then the other thing that I hope you all remember is that we talked about how these transformations impact every single point on the graph of the original function. So shifting right impacts the x-coordinate, and then shifting up impacts the y-coordinate. So here's what I'm going to do. And I'm going to try my best to keep as much visible on the screen as possible. In fact, I'm going to zoom out again. So I'm going to pick a point on the graph of f. Okay, I'm going to pick a nice point so that we can see it really clearly. So there's the point 2, 4. And I'm going to trace where it ends up as a result of these transformations. So check it out. It's going to go right 1 unit. There's 1 unit right. And then up 2 units. So our tradition so far has been to graph G in blue. So I'm going to put this point in blue. And this point is the point 3, 6. So 3, 6 is the point you end up with if you start with 2, 4 and go right 1, up 2. Okay, let's do a few more. So here's another one. Here's 1, 1. So we're going to go right 1, up 2. There we go. So that lands us here at the point 2, 3. Let's do a couple more. So here is 0, 0, our friend the vertex. Same thing happens to it. It goes right 1 and up 2. So it lands there. The point 1, 2. All right, here's another point, negative 1, 1. So there we go, right 1, up 2. So we have the point 0, 3. If you want, you can keep going. It's getting a little crowded on my graph, so I'm actually going to stop. And I hope you all can see that the blue points are now starting to flesh out the same shape. So I'm actually going to go ahead and stop here and draw it in. But really, I'm only stopping because, like I said, my graph is getting crowded. And I really want my graph to be as neat as possible so that it is as clear to see things as possible. Right, so there. And of course it continues like that. So again, if you want to do more points, you can do more points. But I just wanted to show you those few. The other thing I wanted to show you in this example is that literally every single point on the red graph got moved the same way. It got shifted right 1, up 2. So if I pick some random point on the graph of F, so I'm going to pick a random point here. Okay, I don't know what it is. I'm not particularly interested. Its coordinates are x, y. Well, look, to get a point on the graph of G, I'm going to go over 1 and then up 2. So we're going to cheat a little bit because it's not perfect, because my graph isn't perfect. But see, if I started with some point x, y on the graph of F, that's going to end up at a point whose x coordinate is x plus 1 and whose y coordinate is y plus 2. So what I just did there is something that I will refer to as coordinate analysis. So let me write that zoomed in down here. Coordinate analysis is summarizing what is going to happen to every single point on the graph of F. So if x, y is a point on the graph of F, after the shift right, its x coordinate becomes x plus 1, and after the shift up, its y coordinate becomes y plus 2. So what this does is it acknowledges that the transformations impact all of the points the same way. Okay, let's move over here. So I'm going to go over to our second example. Okay, so example number 2, we're looking at the square root of x as our base function, the function that we're starting with, and there it is, right? So this is a shape we worked with in the last lesson, so I'm hoping that it's become a little bit more comfortable now. And then the transformed function is the square root of x plus 2 minus 3. So we're going to do exactly the same thing. And I really encourage you, if you can, to follow along with me, right? Don't just wait for me to write it. Kind of maybe even pause my video and see if you can anticipate what I'm about to say. So we're going to write out the transformations. Again, I'm going to underline them. So x got replaced with x plus 2, and then we have this minus 3 on the outside. So the replacing of x with x plus 2 is a shift left 2 units, which again, this is a transformation that impacts the x coordinate, right? And then the minus 3 is a shift down 3 units. And that impacts the y coordinate. So let's do exactly the same thing that we did in our previous example here. So I'm going to take a bunch of points on the graph of F, which is this black graph. So here is 0, 0. And I'm going to perform these transformations. So I'm going to shift left 2 and then down 3. So our tradition has been graphing G in blue, so there it is. So 0, 0, ended up at the point -2, -3. Okay, let's do another point. So let's do 1, 1. 1, 1. Same thing. we're going to shift left 2, and then we'll go down 3. 1, 2, 3. Again, plot that point in blue. So you can see its x-coordinate is -1 and its y-coordinate is -2. Let's do one more point. So you remember how we were saying that with the square root, looking at perfect squares will get you nice points. So here's a point. So the point 4, 2. Same thing. We're going to go left 2 and then down 3. So there it is. And that's the point 2, -1. Just like in the previous example, if you want to, you can flesh out more points. But for the sake of time, and also I think we can all agree, these blue points are starting to flesh out the shape. If you want, you can do another one. So for instance, I won't walk through it, but I'll let you play with it if you want to. Here's another nice point, right? This one up here on the graph of the square root of x, that's 9, 3. So you could trace where it ends up and make sure that it fits with the general scope of the graph. But I'm going to go ahead and draw the graph in. As always, graphs are not meant to be super perfect, right? But there's the basic gist. Okay, that seems pretty good. Again, if you want to sort of remind yourself, this graph goes on forever. You can put a little arrow on it if you want to. And I want to do one last thing to do sort of that coordinate analysis piece that I was talking about in the last example. So if I picked any old point, like, I don't know, let's do this one. This is some point on the graph of f. I'm not careful about what it is. I can trace where it'll end up because it too will get shifted left 2 units, right? So it'll go to about there and then down 3. So that'll land us about there. And this blue point, its x-coordinate is x minus 2 because we started at x and we went left by 2, and its y-coordinate is y minus 3. So what that tells us, again, I'm calling it the coordinate analysis. I'm going to zoom in down here so we can write it really well, right? So coordinate analysis. If I start with some point xy on the graph of f of x, and then I do both of these transformations on it, the shift left will cause the x-coordinate to go to x minus 2, and the shift down will cause the y-coordinate to go to y minus 3. So that is the coordinate analysis for this couple of transformations. What we have still to talk about with transformations are reflections and then also stretches and compressions. Stretches and compressions are not going to be a big focus for us, so I will probably just do one quick lesson on those, but watch for lessons on reflections coming soon. I'll see you later. Bye.